Hi, I'm Rebecca Rosamond. Solar power. Why use it? And what is it? Let's talk about that. 80% of all U.S. power needs can be met by renewable electricity generation from technologies that are available today, and 50% of that could come from wind and solar power. By making the transition to solar power, we could reduce CO2 emissions by 80%. This reduction in air pollution would drastically improve public health. That alone is reason enough to make the switch. The first true modern photovoltaic cell was developed in 1954 by Bell Laboratories. This cell had only 4% efficiency. Over the next decade, the efficiency increased to 10%. Today, the highest recorded efficiency has reached 46%. Photovoltaic cells generate electricity when photons from the sun strike the panel and excite electrons. This causes the electrons to break free from the atoms in the semiconductor, which creates a current. Photovoltaic cells consist of 4 key elements: an anti-reflective coating, a semiconductor material, positive and negative conductors, and a reflective layer on the bottom. The anti-reflective coating makes sure that the light makes it to the semiconductor material instead of reflecting back off the top of the panel. The positive and negative conductors serve to capture and direct the electrons knocked loose from the semiconductor, producing a current. The reflective layer allows the photons to be reflected back up to the semiconductor layer and attempt to free more electrons instead of being wasted as heat. The semiconductor layer is the most versatile element of a photovoltaic cell. There are many different semiconductors that can be used in solar cells. However, crystalline silicon is the most commonly used semiconductor because of its abundance and durability. Efficiency in photovoltaic cells is still very low overall, silicon cells only topping out at 27.6% efficiency. The reason for a lack in efficiency in photovoltaic cells is a property of semiconductors called the band gap. Each semiconductor has a minimum amount of energy required to liberate electrons. So while photovoltaic cells are bombarded with photons from many different wavelengths, not all the wavelengths have enough energy to free electrons. One way that researchers have worked around this limitation is by creating multi-junction cells. While most cells only use one type of semiconductor, multi-junction cells use layers of different semiconductors, each with a unique band gap, allowing the cell to use a broader spectrum of light. Solar power holds a bright future for the United States and the world. From cleaning up the environment and improving public health to providing a long-lasting renewable source of power, photovoltaics bring benefits to those who use them. Solar power has progressed leaps and bounds since the first panel in the 1950s and continues to improve, paving the way for a world powered by renewable energy.